Dear friends, welcome back to Data Analytics Talks. In the last video, we have explored HDFS. And in this video, let me elaborate MapReduce. So what is a MapReduce? MapReduce and HDFS are the two major components of Hadoop, which make it so powerful and efficient to use. As you know, MapReduce is a programming model, is a key component of Apache Hadoop framework and is designed to process large volume of data in parallel across a cluster of computers. It consists of two main stages, the map stage and the reduce stage. So remember that there are two major components of MapReduce. One is map and other one is reduce. So you can say map stage, shuffle stage, reduce stage, and output stage. So what is that meaning? So when you upload something to our HDFS, it try to split them into parts, and it will map to data nodes. It will map to data nodes. But as soon as we want to get it back, there is a shuffling happens, and there is a reducing happens, and you get the result. So there is a map stage, a shuffle stage, reduce stage, and output stage. So let me explain with an example. So in the map stage, the input data is divided into chunks and processed in parallel by multiple map tasks. Each map task takes a portion of the input data and applies a user-defined map function to generate key value pair as the intermediate output. So look at this example. We have a chunk of data. It's explaining we have deer, beer, river, car, river, then the same thing is repeated. So we would like to count the numbers of this text. How many deer, how many beer, how many river. So what happens as part of the map stage, this is going to divide into chunks. The first is deer, beer, and river. Second is car, river, and deer, car, beer. So the first chunk of data, second and third. So now this is going to map it to a key value pair, which will say the text and the count. Now deer 1, beer 1, river 1. Then the next node will represent car 1, river 1. And again the next node will say deer 1, car 1, beer 1. So this we are mapping. So whatever we are uploading or inserting, the data is divided into chunks and processed in a parallel multiple map task. Okay. Then now we have something called shuffling. That is the next stage, shuffling stage. So what happens in this stage? So the intermediate key value pair generated by the map tasks are then sorted and grouped based on their keys. This step ensures that all values associated with the same key are brought together. So this example, all the beer brought together like 1, 1. Car is there, how many car? There is 1, 2, again 3. There is 1, 1, 1. Deer 1, 1. River 1, 1. So we have shuffled and sorted and grouped them together, right? So this is shuffling stage. Then coming the reducing stage. What is happening in the reducing stage? So in this stage, the sorted intermediate key value pairs are processed by multiple reduce tasks. Each reduce task takes a group of key value pair with the same key and applies a user-defined reduce function to produce final output. So here we have a user-defined function applied on the shuffled result, that is becomes bear 2, car 3, deer 3, 2, and river 2, right? This is the reducing stage. Then the final stage is output stage or final result. So the output stage, the final output of the reduced task is collected and stored in the HDFS or another designated output location. So the MapReduce programming model provides a high-level abstraction for distributed data processing. It enables developers to write parallel and scalable data processing jobs easily. It allows for efficient utilization of the cluster's resources and handles various aspects such as data partitioning, distribution, and fault tolerance. I hope you understand from this simple example how MapReduce components work together and how various stages like map stage, shuffle and sort, reduce stage, and output stage. Let me continue. So look at the MapReduce architecture. You will see we have client, we have job, Hadoop MapReduce master. Then we have the job parts, the splitting of the jobs. Then we have the maps and reduce function and output data. So what is a client? The MapReduce client is the one who brings the job to the MapReduce for processing. There can be multiple clients available that continuously send jobs for processing to the Hadoop MapReducer manager. So this is the client. Then job. The MapReducer job is the actual work that the client wanted to do, which is comprised of so many smaller tasks that the client wants to process or execute. Then coming to the Hadoop MapReduce master, say it divides the particular job into subsequent job parts. So client is sending jobs and Hadoop MapReduce master is splitting them, dividing them into job parts. A job part, the task or the sub-jobs that are obtained after dividing the main job, the result of the job parts combined to produce final output. Then input data, the data set that is fed to the MapReduce for processing. Then the output, the final result is obtained after processing. So just to repeat, the components of MapReduce architecture is client, job, Hadoop MapReduce master, job parts, input data, and output data. Now we can see another example of a big data which has a JSON format, which is ID and color. We can see that there are 9 objects, and if you want to count the number of objects with specific colors, now this is the input. They have 9 entries in our JSON. It is loaded into the map. That means now this is split as chunks like green, red, green, then yellow, red, yellow, then green, green, yellow. So we have 3 parts. Then we have a reducing. We take all the greens, all the reds, all the yellows together. Then now finally we do the shuffle and you bring the output. Okay, this is example of MapReduce. So MapReduce in the map phase, the input data is divided into split and each split is processed by a separate map task. The map function transforms the input data into intermediate key value pair. These intermediate pairs are sorted and partitioned based on keys. And in the shuffle stage, shuffle and sort, the sorted immediate data is shuffled and grouped by keys. And data with the same keys sent to the same reducer. Then in the reduce phase, reducer task process the group data. The reducer function aggregates and processes the data to produce final output. So MapReduce allows efficient processing of large-scale data, make it suitable for tasks like data transformation, aggregation, and analysis. Thank you very much for watching this video. I hope this was really useful. I hope you were able to understand MapReduce with these examples. Let me know if you have any questions, comments, feedback. We'll try to respond to you. Thank you.